So I'm going to go over the redox worksheet that I put up on to D2L for anybody who has not gone over redox reactions so far, in hopes that this will help you get ready to balance redox reactions for 1212. Okay, so I start out in this worksheet asking about oxidation states, so hopefully this part is a review, and then we'll go over how to actually balance redox reactions. Okay, so remember that we have a order in which we assign as oxidation states. We always assign ions first, ones that are actual ionic species, and then we go on fluorine, then hydrogen, oxygen, so on and so forth. So let's start with the first one. So H2O, we're going to assign hydrogen first. Hydrogen is +1 because it's attached to a non-metal. So this portion of it would be +2 because there's 2 of them. So this portion has to be -2. Next one, we go on to HNO3. We're going to assign the hydrogen first, giving it a +1. Then oxygen would be next. There's -2, and there are 3 of them, giving that portion of it -6. So this has to be +5. And this is asking the oxidation state of each element, not total. So we're looking for that +1 or +2 here. Sodium sulfate, we're going to assign the sodium first because it's a metal, and it'd be +1 because it is an alkali metal. Then our oxygen at -2. There are 4 of them, so this portion of it is -8. There are 2 sodiums, so that portion is +2. So this portion has to be +6 to balance out the charge. Next one, we're looking at phosphoric acid. We assign our hydrogen first at +1. There are 3 of them, so it gives us a +3 for that section. Our oxygen, -2. There are 4 of them, so that gives us a -8 for that portion of it. So in order to balance out, we have to have a +5 here. Bromine, Br2, is elemental, so we have a 0 here. With H2O2, we're going to assign the hydrogen first. It is +1. There are 2 of them, so that portion of the molecule is +2. That means this portion has to be -2 because there are 2 oxygens. We divide that -2 by 2, giving us -1. Okay. Next one, zinc sulfite. The zinc will be +2. As zinc is always +2. The oxygen will be -2. There are 3 of them, so that section equals -6. So this will therefore have to be +4. Here we go again. We have our zinc +4, or sorry, our zinc +2. Oxygen -2. Oh, sorry, this is supposed to be oxygen. There are 4 of them, so that gives me -8 over here. So to balance out that charge, this has to be a -6, or sorry, +6. Here we have an interesting species here. So this is 2 polyatomic ions added together. NH4 plus, NO3 minus, where this nitrogen right here, we're going to call nitrogen 1. And this nitrogen here, we're going to call nitrogen 2. Okay? So, in the first one, Our hydrogen is +1. There are 4 of them, so this portion has to be +4. This is +4. In order to get a total +1 charge for all of our elements, this has to be -3. Okay, let's try the other one. I'm going to actually put it over here. Our oxygen, -2. That gives us 3 oxygens, a total of -6. So this portion of it is -6. In order to sum to that -1, this has to be a +5. And last one, hydrogen is +1. There are 3 of them, so this has to be -3. This next part is a really easy balancing because we're just dealing with metal salts. So let's go ahead. We have sodium going to sodium chloride, iron chloride going to iron. So going from sodium to sodium plus, iron 2 plus, going to iron. We need 1 electron here, 2 electrons here, times by 2 gives us 2Na, 2Na plus 2 electrons, and then it'll balance out. So we just need a 2 here and a 2 here. So there's just simple. If you don't understand these, I can go further into it, but I'm going to actually skip those and go on to balancing in acid and base, because we're not going to do any of these type in our class. We are going to, however, balance in acid and in base, so let's look at these examples as these will be a little more applicable. Okay, as I said in class, the only time that you're going to have oxygen changing oxidation state is if it's in a compound in one state and then an elemental form. So here we have a compound oxygen going to elemental oxygen. So that's obviously changing oxidation states. And there we have chromium going to another state of chromium. So we have H2O2 going to O2. In H2O2, it is -1. We saw that up in the example above. And in O2, it is 0. So it's going from -1 to 0. So we are losing electrons. So this would be oxidation. And then in the other one, Cr2, O7, 2 minus, to Cr3 plus. We're going from chromium, that's +6 to +3, so it is gaining electrons, so this is reduction. Okay, so let's go ahead and follow our steps to balance out these two half reactions. In the first one, we don't have any elements besides oxygen or hydrogen, so we can move on to adding oxygen or hydrogen. Our oxygens are balanced, we just need to add hydrogens, therefore. There are 2 on the left side, we need 2 on the right, so we'll add 2 H plus on the right side to balance out our hydrogens. So we balance out our elements. The next thing we need to do is balance our charge. Sorry, I'm just going to push these a little bit further over here. Next we need to balance our charge. On the left side of our equation, we have a 0 charge because we have no charges in here. On the right side, we have a +2 charge. To balance it out to that 0, we need to add 2 electrons. Okay, on the bottom, first step, balance out our elements other than oxygen and hydrogen. We have 2 chromiums on the left side, 1 chromium on the right. We need to add 2 to the chromium 3 plus. Next, we want to balance our oxygens by adding in water for every oxygen we need to add. There are 7 oxygens on the left side. 0 oxygens on the right side, so we need to add 7 waters. After that, we're going to add H pluses to balance out the hydrogens. We have 14 hydrogens on the 14 hydrogens on the right side due to the 7 waters. So we need to add 14 H pluses over here. And next we need to balance our charge. On the left side of our equation, we have a total charge of plus 12, the 14 pluses from the hydrogen, and then the 2 minus from the chromium oxygen species. So we have plus 12. And then our right side we have plus 6 because we have 2 plus 3 chromiums. So we have an excess of 6 plus charge on our left side versus our right side, so we're going to add 6 electrons. That'll balance us out to have plus 6 on both sides. Now that we've balanced out our elements and our charge, we're now going to balance the 2 reactions electrons to each other. In the top reaction, we produce 2 electrons. On the bottom reaction, we consume 6 electrons. So we need to have these equal each other. So what we need to do is we're going to take this equation right here, we're going to multiply it by 3, giving us 3 H2O2 goes to 3O2 plus 6H plus 6 electrons. We don't need to do anything to the bottom equation because it's good. However, we are going to combine the 2 of them, this one plus this one. We cancel out anything that is the same on both sides. So we have 6 electrons here, 6 electrons here. We have 6 H pluses. We have 14 here. So this would leave us with 8 H pluses here. And that will cancel everything out. Now we add them together. So we have 8 H plus 3 H2O2 plus Cr2O7, 2 minus, goes to 3O2 plus 2Cr, 3 plus 7H2O. So that's our balanced equation. In the end of this, we should have all of our elements balanced out. So if we take any one of these and count them up, they should be equal. So for instance, our hydrogens on the left side, we have 8 hydrogens plus our 6 hydrogens give us a total of 14 hydrogens on the left side. On the right side, we have 7 H2Os, so we have 14 hydrogens on the right side, so we are good. Let's try the next one. So we've got tellurium oxide, so tellurium in a compound going to tellurium metal, so that is obviously changing oxidation state. And then nitrogen, dinitrogen tetraoxide to nitrate, that is also changing oxidation state. We have a different number of oxygens, different number of nitrogens. It's going to end up having different oxidation states. For instance, the dinitrogen tetraoxide, we have an oxidation state of +4. In the nitrate, it is +5. So, and anytime we go from a compound to an element or an element to a compound, we're going to be changing oxidation state as well. So let's put this over a little bit more. Okay, so we have tellurium oxide going to tellurium. So tellurium has a positive oxidation state on the left, and then it goes to neutral, so it is becoming more negative, so this is reduction. And then for our bottom one, dinitrogen tetroxide going to our nitrate ion. We're going from +4 to +5, so we're becoming more positive, so this would be oxidation. And again, let me just move this over a little bit. There we go. Okay, so same steps. Every element will be balanced besides oxygen, hydrogen, then hydrogen, then electrons, then balancing out the 2 equations. So on the top one, our telluriums are balanced, so we're going to move on to the bottom one. The bottom one, our nitrogens are not. I'm actually going to start using a different color. So I'm going to put 2 here. That'll balance out my nitrogens. Next, I'm going to balance out my oxygens. On the top equation, I have 3 oxygens on the left, 0 oxygens on the right, so I need to add 3 waters. In the bottom one, I have 4 oxygens on the left, 6 oxygens on the right, so I need to add 2 waters. Okay. After that, we need to balance out our hydrogens. We have on the top 6 hydrogens on the right, 0 on the left, so we'll add 6 H pluses. Bottom, we have 4 on the left, 0 on the right, so we add 4 H pluses here. Next, we balance our charge. In the top equation, we have a +4 on the left and then a 0 on the right, so we have an excess of +4. So we need to add 4 electrons, and that will give us a 0 charge on the left, 0 charge on the right. In the bottom one, we have 0 net charge on the left, and we have a net charge of +2 on the right, so we need to add 2 electrons here. That would give us 0 on both sides. Then if we look, we have 4 electrons in the top equation, 2 on the bottom, so we need to multiply the bottom equation by 2. Okay. That'll give us 4H2O plus 2N2O4 goes to 4NO3 minus plus 8H plus 4 electrons. We're going to combine that with this equation. And what we get at the end, after we cancel things out, so 4 electrons will cancel out. All 6 of those hydrogens will cancel out, giving us 2 left here. These 3 waters will cancel out, leaving us with 1 water here. And then we combine. So we have H2O plus TeO3, 2 minus, plus 2N2O4 goes to Te plus 4NO3 minus plus 2H plus. We're in acid, so it's good that we have H pluses, or it's fine that we have H pluses, and all of our elements are balanced. So we are done there. Okay, for our next two, we're going to be in base. So we will have an additional step or steps after we're done with this. So we have O2 going to Cr, chromium 3 plus, H2O2, Cr2O7 2 minus. Should look very similar because we just did a problem just like it. So we have O2 going to H2O2, and then we have Cr3 plus going to Cr2O7 2 minus. So O2 to H2O2 is becoming more negative, so this is reduction. And then Cr3 plus going to Cr2O7 2 minus is oxidation, because we're going from +3 to +6. Okay, let's go ahead, balance out those elements. Other than oxygen and hydrogen, top one's good, bottom one we added 2 there. Then add in our oxygens, top is good. Bottom will look like that. Then our hydrogens, add 2 H pluses to the top one, top left, add 14 H pluses to the bottom right. And then we balance our electrons. Plus 2 electrons, plus 6 electrons, Next, balance out our electrons by multiplying this by 3. Gives us 6 electrons plus 6H plus 3O2 goes to 3H2O2. Then we cancel out. 6 electrons, 6 electrons, 6 H pluses. We'll cancel out with 6 there, giving us 8, and we combine. Seven H2O plus 3O2 plus 2Cr3 plus goes to 3H2O2 plus Cr2O72 minus plus 8H plus. Now, we are now in base. So in this case, we need to balance out, or we need to neutralize any H pluses with hydroxides. So I'm going to add 8. There's 8 H pluses on the right side, so I'm going to add 8 hydroxides to both sides. This will combine to give me 8 waters, which will cancel that. All of those, sorry. I'll cancel out all of those waters and leave me with 1 water here. And now we have 8 OH minus plus 3O2 plus 2 Cr3 plus goes to 3H2O2 plus Cr2O72 minus plus H2O. Okay, one more example. So we have lead 2 plus going to lead 4 plus, and then we have iodine 5 plus going to iodine 0. Okay, so if we're going from +2 to +4, this is oxidation. And then we have iodine 3 plus going to I2 or I0, so this would be reduction. Okay, so we're going to balance out our elements. Then we're going to balance out our water. And then our hydrogens. Then our electrons. So we have +2 on the left side, +4, so we need to add 2 electrons. And then we'll balance out our electrons on the bottom one. We have +10, and then 0, like so. So we multiply this by 5. Okay. After that, we can balance out. We've balanced out our 2 equations, so we just combine. So 10 electrons go away. All 12 of those. 12 of those, leaving us with 8 there. And then all 6 of these waters go away. 6 of these going away, leaving us with 4. And then we combine our two equations to get 4 waters plus 5 Pb2 plus 2 IO3 minus goes to 5 PbO2 plus I2 plus 8 H plus. And again, our last step here is going to be neutralizing all the H pluses with hydroxides. So we're going to add 8 H or hydroxides on both sides. These will combine to give us 8 waters. So we will cancel out the waters here, cancel out 4 of the waters here, and we will combine in our total equation to give 8 hydroxides plus 5 Pb2 plus 2 IO3 minus goes to 5 PbO2 plus I2 plus 4H2O. Okay. Hopefully this all makes sense to everybody, but let me know if you guys have any issues or need additional help. I know some of you guys have not gone over this in 1211 for whatever reason, but I want you guys to understand this. So if you need more help, let me know. You guys have a great weekend.